Hello, Algebra 2 students. Arithmetic sequences and series here. Listening to songs that start with the letter B, starting with Frank Sinatra, Blue Skies. I'm a big Sinatra fan. Let's not dilly-dally, let's get right to it. Start with some definitions, as usual. Sequences. So sequences are number patterns. In this case, we're talking about arithmetic sequences. In an arithmetic sequence, the difference between consecutive terms is constant, and that constant is the common difference. Common, constant, it's the same each time. And what we're doing is adding to find the next term of a sequence here. The arithmetic mean of any two numbers is the average of those numbers. It's the halfway point between them. And I forgot to fix that typo. There we go. All right. Then we have series. A series is the expression for the sum of the terms of a sequence. In an arithmetic series, it's a series whose terms form an arithmetic sequence. So it's adding all the terms. So, for example, if I was talking about the evens, so a series of 2, 4, 6, 8 would be 2 plus 4 plus 6 plus 8, etc. Like so. All right, example time. Oh, no, I lied. Formula time. Don't be afraid of these formulas. They might look daunting. However, they are on your formula sheet for the SOL test, along with all the other sequence formulas. This first one here, to find any term of an arithmetic sequence, the nth term to be exact, that would be the number of the term, would be n. This is the formula. The nth term is the first term plus term number minus 1, the quantity, times that common difference. So it's 1 less than the number of the term times that difference change from the first term. Okay, and that actually, there's no need to have these formulas on the SOL formula sheet, but they give them to you anyway. These are totally derivable easily. Remind me, we'll talk about Gauss in class for this one, but this formula is the series formula to find the sum of a certain number of terms of an arithmetic sequence. You have the sum of a certain number of terms, is that number of terms, times the first plus the nth term, the quantity, all divided by 2. Most of the time you will see this written a different way, however, so I'm going to write it again. Not much of a change, just a rearrangement, but that's the way it looks on the formula sheet. Okay, let's apply those formulas. Well, let's apply the concepts first. Bohemian Rhapsody by Queen is next. All right, is the sequence arithmetic? If so, find the common difference. So let's look. All right, 2 to 4 is plus 2. And that's plus 4. No, that sequence is not arithmetic. Look at the next one. 6 to 12 is plus 6. 12 to 18 is plus 6. Yes. And that common difference is 6. We don't put plus 6 or minus 6 or anything like that. We put either a positive common difference for a sum that's going up, and we put a negative common difference if it was a sequence going down. Next one, plus 3, plus 2. Nope. Don't even need to go any further. All right, plus negative 3. Plus negative 3 plus negative 3. Yes. Sorry, I forgot the yes part. And the common difference here is negative 3. Next example. All right. Suppose you participate in a bikeathon for charity. The charity starts with $1,100 in donations. Each participant must raise at least $35 in pledges. What's the minimum amount of money raised if there are 75 participants? Well, this lends itself to an arithmetic sequence, so we're going to start by talking about it as if we have an A1, all right, first term, and that first term here, oops, must have hit the wrong tool. That first term is going to be $1,100. $1,100, okay? We know that we also have a common difference of 35. So I'm having a little technical difficulties today. Put this back where it's supposed to be. And we have our number of terms, which, don't let that one confuse you. Your number of terms here is going to be 76. Because if 0 participants at the first term is $1,100, then the number of terms we're dealing with here is 76. Because if $1,100 is no participants, and we have 75 participants, we're going to be going up 76 steps. So, A sub n equals A sub 1 plus quantity n minus 1 times d. That's the formula. Remember, you will be given that formula. We are finding the 76th term in the sequence. So we're going to put in A1. We're going to plug in n, 76, and we're going to plug in d. And then all we have to do is the math there on that right-hand side, which I can punch right in my calculator. Comes out to $3,725. And that's it for the problem. So that's not difficult. Let's try another. Okay, arithmetic means, we're finding the missing term of the arithmetic sequence, and that means we're finding arithmetic means. Arithmetic means. So all we have to do here is what? That's right, add them and divide by 2. So 110 plus 84 is 194. Cut it in half. 97. Oop, funky looking 9. There we go. All right, what about 24 and 57? When you add that together, you get 81. So 40.5 would be the middle term in the sequence. So that is really not difficult at all. If you had multiple spaces, we'll look at those in class, a little bit more difficult, but still not that hard if you think about what you're doing with the math. Another example, in arithmetic sequence, the first term is 4 and the common difference is 9. Which term is the number 184? All right, well, let's write down our formula. A sub n is a sub 1 plus the quantity n minus 1 times d. What do we know? We know a1. We know d. We don't know n. But we do know what an is. The nth term is 184. So if you look, you only have 4 variables here. an, a1, n, and d. I have 3 of the 4. I can find the 4th one. So plug in what you know. 184 is the nth term. We're just finding out n. A1 is 4. I don't know n, so I'm going to leave it a variable. And the common difference there is 9. So distribute that 9. 9n minus 9, which makes this 9n minus 5. I'm just going to flip it around because I'm more comfortable this way. There we go. 9n equals 189. Divide by 9, n equals 21. It's the 21st term. So far, not difficult at all, just application of formulas. Okay, this one is a series. An embroidery pattern contains 5 rows of green cross stitches, where the first row contains 5 stitches and the last row 13. How many total stitches were made for the pattern? Now, obviously, who cares, but there are lots of good examples for this stuff. I just chose this one because it's simple and the numbers are nice and small. So, formula for the series. S sub n equals n over 2 times a1 plus an. So, first I need to think about what I'm talking about here. Well, I have 5 rows. So, it's 5 terms in the sequence. We know that if n is 5, we can put the 5 there. We know the first term and the last term. So, the first row has 5, and the last row has 13. Okay, and yes, obviously it should have said so in the problem that we assume that is a sequence, that it's a few more stitches each row. We didn't need to know the common difference, just all we need to know. All right, and then you just go ahead and do the math on the right-hand side there, and it comes out to be 45. 45 stitches. Cruising right along, 3 more slides. Okay, summation notation. So this is a little bit different. This is a little bit new, not something that we've seen in a while. So let's start with Bad Romance, the Glee version, because, Lady Gaga, she's a little weird. Anyway, summation notation. Capital sigma means sum of. Sum of what? Sum of the things that come after. So whatever the elements are here, this means add them up. From the first, index of summation, so from the first, the starting point, the lower limit, all the way to the last, which is that upper limit. So we could be talking about something as simple as the sum of the numbers 1 through 100. And it would look like this. And all that's saying is add the numbers 1 all the way till you get to 100. Let's try a couple. Let's try writing these in summation notation. So what are we adding together here? 3 plus 6 plus 9, etc. So I have my sigma. And I know my n, my upper limit is 33. And we'll use an n here, and we're assuming we're going to start with 1. So 33 terms starting with 3 plus 6 plus 9, etc. Well, if that's the first term, 3 is the first term, what do you do to a 1 to get a 3? You could add 2, but that's not really going to help us because that doesn't do that, get that arithmetic series going. It's going to be the same difference each time. So since it's a difference of 3 each time, we didn't have to realize here that this is 3 times n. Because 3 times 1 would be 3, 3 times 2 would be 6, 3 times 3 would be 9, and so on. So this right here represents this sum. Okay, the next one's a little easier. 1 plus 2 plus 3 plus 4. Well, obviously, we're just adding the numbers together, and they want us to go through 6. So we just put an N there. All right, last one's a little bit tougher. What's the common difference here? How is it changing each time? Common difference here is 5. Okay, if that's the common difference and the first term is 3, what I want to know is, how do I find the next terms in the sequence? Well, I would use my formula. Well, it's a sub n is a1, which is 3, plus n minus 1 times the common difference, which is 5. Let's simplify that. Simplify that down, we have 3 plus 5n minus 5. And that's 5n minus 2 when we simplify it all the way down. So that's the formula that we put here. 5n minus 2 from n equals 1, which it does give you. 5 times 1 minus 2 would be 3, up until n equals 9. Let's test it out for the other terms just to make sure it's working. 5 times 1 minus 2 would indeed be 3. 5 times 2 would be 10, minus 2 would be 8. 5 times 3 would be 15, minus 2, 13. 5 times 4 would be 20, minus 2, 18. Okay, we're good to go. Okay, so we used the formula, this formula, to help us figure out our summation notation. Last problem, and we're done with this video. Okay, now we're actually do these examples. I actually only gave you one in your notes, so I'm going to, real quick, I'm going to do something fancy here. I'm going to color over this other one. We're going to pretend we don't see it, because we don't want to do 2 examples. 1 example is plenty. Pretend it's not here. Pretend what's not here? Okay, anyway. All right, so I am actually finding a sum here. What sum? Well, I need to know how many terms I'm dealing with, and I need to know my first term and my last term. So my first term would be plugging in 1 for n, which comes out to be 2. The last term will be plugging in 5 for n, which comes out to be negative 10, right? Right. And then the n, okay, so this is a1, and this is an, which is 5, and n is 5. And there you go, we're finding the sum of the first 5 terms, 5 over 2 times, and then we plug these in. Now, as you can imagine with permutations and combinations, you had all that good calculator stuff. As you can imagine with this, lots of good TI-84 action. Okay, we're going to be able to do most of this by calculator. So just to finish this off, if I go ahead and do the math here, we get negative 20. Are we sure that's right? That just doesn't seem right. Well, let's try it out. Perfect timing. It's the end of the song, so I'm going to pause it, and I'm going to go ahead and do this by hand and see what I get for the sum. Yep. Negative 20. I know it's a little messy here in the corner because I was trying to rush, and with a stylus you can't really rush like that, but it does come out to be negative 20. Hope you enjoyed. Hope it doesn't end up too long. See you guys in class.